Good evening. My name is Aaron Lang. I'm currently a sophomore at Waubonsie Community College, and today I'm going to be talking a little bit about Jocelyn Bell, who discovered the pulsar and all the applications that it's had to modern science since. Allow me to introduce to you Jocelyn Bell. She first attended college at the University of Glasgow, where she earned her bachelor's degree in natural philosophy, aka physics. She then continued her studies at the University of Cambridge, where she earned her PhD in 1969. While she was there, she worked with Professor Anthony Hewish to construct the interplanetary scintillation array in hopes of studying quasars. Here Bell is pictured with the graph of her discovery. She didn't know it at the time, but those spikes indicated to her that there was something abnormal going on. And we now know that that was concrete evidence of the pulsar. Now, in order to better understand her discovery, we need to better understand the instruments that were used in that discovery. Here we can see a parabolic radio telescope. Now, radio emission was first reported by Carl Jansky in 1933, but not until 1944 did we get the first radio map of the sky provided by Grote Reber, who's actually from Wheaton, Illinois. Now, this is just a helpful little diagram to help us better understand how the radio telescope works. See, the dish, the big circular part, acts as a reflector, bouncing all of the radio waves coming in from outer space to a single focal point where the receiver is. Now, this receiver then magnifies the radio waves, giving us the images that we see in modern science today. This is a more modern computer-generated image of Bell's discovery, the pulsar. Now, as you can see, it looks a little too uniform to be something that we would see with the naked eye. That's only because we can only see so much of the wavelengths of light. We're only able to see what's in the visible light spectrum. If you come back to this graph over here that we just showed, you'll see that visible light only takes up this small portion right here. Now, the gases that are surrounding the neutron star, which is what a pulsar is, are somewhere between radio and microwave. So the wavelengths are too long for us to pick up with our human vision. Now, this is a diagram of a pulsar. It's a little bit easier to tell what's going on. At the center is a very fast spinning neutron star. Now, it's rotating so quickly that the axes at either pole, well, actually, because it's rotating so fast, it creates its own magnetic field. This magnetic field then allows the star to have poles, just like the Earth, north and south. I mean, if stars have directions, I don't know. What happens is when this star completes a rotation, the radiation beams are shot from the poles in a straight line. Now, this line is not just arbitrarily drawn through that star. The line represents where the poles are on the star. As that star rotates, it sends signals to the radio telescopes that we saw before. This is a quasar. This is what Bell and her team were originally trying to study at Cambridge in 1967 when she discovered the pulsar. It's a very luminous, active galactic nuclei with a black hole at the center. It's surrounded by a gaseous accretion disk, and that's what forms on the outside here. Now, this is theorized to be the start of a galaxy, or maybe the end. We're not old enough to know what happens when galaxies die. This is Professor Anthony Hewish, as mentioned before. Now, the reason he's significant in Jocelyn Bell's story is because he was the cause of much controversy regarding the Nobel Prize in 1947 that many people should have been awarded to Bell. In 1974, 2 Nobel Prizes were awarded in physics, one to Martin Ryle for his work in developing radio aperture synthesis, and the other to Anthony Hewish for the discovery of the pulsar. Now, even though many people credit Bell with the discovery of the pulsar, she wasn't bitter for this. She was actually very humble, even in her youth. But don't feel too bad for her. She's actually received a lot of recognition for her work in science. I mean, just a quick look at her Wikipedia page gives some insight into the incredible awards and honors that she's received over the years, including the Institute of Physics renaming their award for early career female physicist the Jocelyn Bell Burnell Maudlin Prize. And lastly, I'd like to show you a picture of the black hole. Now this was taken as recently as April of this year, and the reason that it's important is Bell's often known, from at least what I've read in the interviews I've watched, to underplay her achievement in the discovery of the pulsar. But without the discovery of the pulsar, we probably wouldn't be able to have this image of a black hole. And what she didn't know at the time was she laid the groundwork for proving Einstein's theory of relativity.